What is artificial intelligence? It's a question that echoes through the halls of science and right into the very fabric of our modern lives. At its core, the idea is simple, but also pretty profound. We're trying to build machines that can think, not just like a calculator adding numbers with cold, hard logic alone, but in a way that actually mirrors us. We want these machines to learn from experience. We want them to solve problems they've never seen before. We want them to understand the subtle dance of human language. Artificial intelligence, or AI, is a grand endeavor to breathe a spark of our own intelligence into silicon and circuits. You might think of artificial intelligence as something far off in the future. Maybe you picture gleaming robots in a sterile laboratory, or a supercomputer straight out of a science fiction film, but the truth is far more intimate. AI is already here. It lives in your pocket. It whispers in your ear. It's woven so seamlessly into daily life you might not notice. It's the silent partner in modern life, working behind the scenes to make things a little bit easier, a little bit smarter, a little more connected. We're living in the age of AI, whether we realize it or not. Think about the smartphone in your hand, a gateway to this world. The dream of an artificial mind isn't a new one. It's actually as old as stories themselves. But the scientific journey toward AI began much more recently. In the mid-20th century, a handful of brilliant pioneers began to wonder, could a machine be made to think? The official birth of AI is often traced to a summer workshop in 1956 at Dartmouth College. A small group of mathematicians and scientists gathered with a bold proposal to explore the conjecture that every aspect of learning early AI programs showed computers could solve algebra word problems, prove logical theorems, even speak simple English. Researchers were amazed at how quickly machines could master tasks once seen as uniquely human, but this initial optimism soon ran into a wall. Funding dried up and progress slowed. Then two things happened. First, computing power grew exponentially, following Moore's law. Second, new techniques, especially machine learning, and the explosion of data from the internet created the perfect storm. So how does a machine actually learn? It's honestly one of the most fascinating questions in all of science. The main idea that powers most modern AI is called machine learning. Instead of writing a program with step-by-step instructions for every possible scenario, we create a program that can learn from data. Imagine you want to teach a computer to recognize a picture of a cat. The old way would be to try and write rules, like a cat has pointy ears, whiskers, fur, a tail. But that's just too brittle. What about a cat with its ears back, or a cat without a tail? There are way too many exceptions. Machine learning takes a different path. We show it examples. We feed it thousands, even millions of pictures labeled cat, and pictures labeled not a cat. The AI, often a neural network modeled on brain connections, then gets to work. At first its guesses are random. It makes mistakes, then adjusts its internal connections. Over millions of examples it builds an internal representation of a cat. The applications of this powerful learning ability are no longer confined to the digital realm. Artificial intelligence is stepping out from behind the screen and into the physical world, acting as a new kind of partner in some of our most critical industries. It is transforming how we work, how we stay healthy. An AI system can be trained on millions of images, X-rays, MRIs, pathology slides, and learn to spot subtle signs like cancerous tumors or early diabetic retinopathy, sometimes with greater accuracy than a human expert. It does not replace the doctor, it assists them. Look also at our roads and highways. The dream of a self-driving car is a direct result of advances in AI. Equipped with cameras, radar, LiDAR, these vehicles generate a torrent of data every fraction of a second. The AI processes it instantly, detecting cars, pedestrians, traffic signs, predicting trajectories, and making split-second decisions. That small chat window? You might be talking to an AI chatbot. It can answer common questions, guide you to the right product, or help you track an order, 24 hours a day. AI handles routine inquiries and frees humans for complex, sensitive issues. Across countless industries, AI is streamlining operations, improving efficiency, and reshaping customer service. It is a new set of hands and a new kind of mind working alongside us to build our future. The potential benefits of artificial intelligence stretch far beyond convenience and efficiency. We are standing on the precipice of a new era of discovery, one where AI could help us solve some of the most profound and persistent challenges that humanity has ever faced. By augmenting our intelligence with machine speed and pattern recognition, we might unlock solutions beyond our reach. The promise of AI is the promise of acceleration, the acceleration of science, creativity, and human progress itself. An AI can analyze complex biological data, simulate molecular interactions, and predict properties of new compounds before they are synthesized. This could dramatically speed discovery for diseases like Alzheimer's cancer. In climate science, AI can model complex systems more accurately, helping us develop strategies to protect the planet. A farmer in a remote village could use an AI-powered app to diagnose crop diseases. AI can democratize expertise and opportunity. A student anywhere can have a personalized AI tutor that adapts to their learning style. AI is not here to replace artists, but to provide a new paintbrush, to spark melodies, help writers, and generate design variations for architects. With every great technological leap, there come shadows. The fire that warms us can also burn us. Artificial intelligence is no different. As we race to build ever more capable systems, we must also walk with caution. We must shine a light on the challenges and ethical dilemmas that arise from this powerful technology. One of the most immediate concerns is the impact on jobs and the economy. AI is exceptionally good at automating tasks that are repetitive, predictable, and based on data analysis. This includes jobs in manufacturing, data entry, customer service, and transportation. As AI becomes more capable, some jobs will be displaced. How do we support the workers and communities affected by this transition? How do we retrain our workforce for new roles that emphasize creativity, critical thinking, and emotional intelligence? Another deep challenge lies in bias and fairness. An AI learns from the data we give it. If that data reflects society's prejudices, the AI will learn and amplify them. An AI hiring tool might favor certain demographics. A loan algorithm might deny credit to entire neighborhoods. Because these systems often operate as black boxes, it can be hard to understand decisions. We must make AI fair, transparent, and accountable. In a world increasingly shaped by artificial intelligence, it is easy to focus on the machine. We marvel at its speed, its power, its ever-expanding capabilities. But in doing so, we risk overlooking the most important part of the equation: us. The rise of AI does not diminish the value of human intelligence, it highlights it. Empathy, creativity, critical thinking, moral judgment, collaboration, trust building, inspiration. Our role is to be the pilot, not the engine. We must define its purpose, set its goals, and ensure its application aligns with our values. Therefore, the most important investment we can make is not just in technology, but in ourselves. We must cultivate lifelong learning, adaptability, and emotional intelligence. We must encourage the arts and humanities just as much as science and engineering. The more intelligent our machines become, the more important it is for us to become wiser, more compassionate, and more deeply human. We stand today on the shore of a vast, uncharted ocean. The journey into the age of artificial intelligence has only just begun, and the map is still being drawn. We have taken the first tentative steps, creating systems that can see, hear, and learn in narrow domains. But the horizon is filled with possibilities we can only begin to imagine. What happens when these narrow intelligences begin to connect and combine? What discoveries await us when we apply AI to the greatest mysteries of science and the human spirit? The future of AI is not a fixed destination, it is an open-ended question. Capabilities that were science fiction a decade ago are now commonplace. This rapid evolution invites us to remain curious and engaged. It is not enough to be passive consumers. To navigate change wisely, we must all become students of AI, understanding how it works and its societal implications. We do not all need to be programmers, but we must develop a basic understanding to participate in decisions about development and deployment. They will learn from the data we provide, the goals we set, and the examples we show them. In a way, they will be a mirror, reflecting our priorities, our biases, our hopes, and our fears. We are building machines that can learn, but what will we choose to teach them?